The instructions are probably the trickiest part here. If you don't get the first part right, the setup, it's going to mess everything else up, obviously. So watch out when we graph these. X plus 3 squared in Desmos should look something like this. 3 minus x in Desmos should look something like this. But they say the x-axis, bounded below by the x-axis. So the only place in this graph where the x-axis and these two curves have a region bounded is right here. First time I did this problem, I was like, okay, you got two curves, you want me to find the area between these two curves. But no, what they're looking for is this area here. So that's a little trickier because it starts on the left as a quadratic and it ends on the right as this straight line here. So to find that area, we want to integrate from, this is -3 on the x-axis, to 0. That's where it's going to switch. That's where it looks like it's going to switch. We should make sure, because to find out where these two places intersect, we should set these two equal to 0. They might not actually intersect at 0 now that I think about it. We want to know where this quadratic crosses with this line. So set the two equal to each other. And then to solve that equation, I'm going to square that parentheses. I'm going to subtract that 3 and add that x to both sides. And then when I factor, that's x plus 6 and x. Oh, good thing I did it because they don't cross at 0. Two numbers that multiply to be 6, but out to be 7. Set each factored piece equal to 0. So you get x is -6 and x is -1. So the -6 intersection is this one over here. So they actually cross at x equals -1. I should have probably done a bit better of a job with my graph. So I want to start from where this crosses the x-axis, which is at -3, because if you plug in -3, you get y is 0. And then I want to end at -1 for this first function. And I'm going to add that region that's found by picking it up right at -1 and going all the way until this crosses the x-axis again. So that would be at 3. And you could do that by setting this equal to 0. Put a 0 in here and solve. So you get x is 3. Okay, and then when you find those two integrals, plug in the limits of integration, add them up, and then you're done. So this antiderivative, you could expand that to be x squared plus 6x plus 9, or you could recognize that the antiderivative is going to be x plus 3 to the third over 3. Either way. Let me do the expanded way too so you can see that. If I do x plus 3 squared, it means I'm writing the parentheses off to the side and multiplying it to itself like this. Okay. So if I do that, I'm going to have x squared plus 6x plus 9. And over here, I don't need any funny business because I'm going term by term. The antiderivative here is going to be 3x, and then it's minus x squared over 2. Limits of integration from 1 to 3. So the antiderivative term by term here is x to the third over 3 plus 3x squared plus 9x from -3 to -1. And then limits of integration over here, if I plug in 3 times 3 is 9. And then we're subtracting 9, so 3 squared is 9 over 2. And then we need to subtract what happens when we plug in the lower limits of integration. -1 times 3 is -3. -1 squared is 1, so that's 1/2. And then plugging in upper and lower limits of integration, this is -1 over 3 plus 3 minus 9 for the first one. Then if I subtract that by the lower limits of integration, plugging in -3, so -3 squared is -27, but -27 divided by 3 gives us -9. -3 in here, that's 9. 9 times 3 is 27. Then 9 times -3 is -27. So over here I'm going to leave the fraction for right now because maybe it'll combine well with something else. So subtract a -3, that means add. Subtract a -1/2, that means add. And over here I got -1/3. 3 minus 9 makes -6. And then inside the parentheses, that's just -9 because those cancel. So that's now +9 because of the negative sign on the outside. So we got negative 1/3. 9 plus 9 is 18. Minus 6 is 12. Oh, and I forgot the 3 over here. 9 plus 9 is 18. Minus 6 is 12. 12 plus 3 is 15. And then negative 9 halves plus 1 half is negative 8 halves, or in other words, negative 4. So that's now 11 plus, let's 11 subtract 1/3. So that's 33 over 3 subtracted by 1/3. So we got 32 over 3 for our final answer here.